back for the post-lunch session of day 2 of the NGV India Summit, 7th edition. I hope you've all had a good lunch. We now have a panel discussion, hydrogen as a new player in clean mobility fuels mix. This time I'm going to read out, call upon the panelists one by one, and finally the moderator. As I do that, I request you to please come up and take your place on the dais. I would like to mention here that Mr. Shaji John, Senior Vice President of Omnium India Private Limited, who was supposed to be here, is not able to make it. He has expressed his regret. And so the first panelist that I'm calling is Mr. Alok Sharma. Mr. Alok Sharma is the Executive Director at Center for High Technology under Ministry of Petroleum and Natural Gas, and he has held this post since November 2021. He's a chemical engineer and MTech from IIT Delhi. He has over 32 years of experience at Indian Oil, including R&D and refinery, including the areas of process, projects, and production. He has been instrumental in setting up hydroprocessing, gasification, biofuels, hydrogen, and fuel cell-related facilities at Indian Oil's R&D. An expert in hydroprocessing, he has excellent knowledge of energy and transition aspects. He's also a member of the International Association of Hydrogen Energy, and he's the treasurer of Hydrogen Association of India. Mr. Sharma, thank you very much for agreeing to be a part of this panel. Our next panelist is Dr. A.P. Singh. Dr. A.P. Singh is the former Joint Chief Controller of Explosives, Petroleum and Explosive Safety Organization under DPIIT, MOCNI, Government of India. He is an MSc Chemistry and a doctorate in chemical engineering from BHU, Varanasi. And in 1998, he joined PESO at Guwahati and served almost in all regions of India. He has superannuated on the 28th of February last year from PESO Agra, and he's now extending his expertise to a few companies in the oil and gas industries, especially in green energy. Dr. Singh, thank you very much for agreeing to be a part of this panel. Our next panelist is Mr. Hiren Mehta, the Chief Commercial Officer, Acme Group. Mr. Mehta is responsible to promote energy transition from fossil fuels to renewable fuels, work with various stakeholders to fast-paced energy transition, negotiate and execute long-term off-take agreements, and innovate techno-commercial solutions to make renewable fuels affordable. He has previously worked in the LNG industry with H Energy and BG Group. His career has spanned more than 22 years of experience in national and international marketing, business development, strategic planning, etc. Thank you very much, Mr. Mehta, for joining this panel. Our next speaker is Mr. Rohit Kumar. He is the Secretary General, Carbon Markets Association of India. We had him yesterday also. Welcome back, Mr. Kumar. He has more than 2 decades of experience in industry relationships, policy development and advocacy across sectors, project development focusing on environment and sustainability, and implementation of SDG at the community level, and implementation of outcome-driven campaigns at the grassroots level. He is currently working as the Secretary General of the Carbon Markets Association of India, which is committed to enabling India in its journey towards net zero future. Mr. Kumar, welcome. And finally, may I call upon the moderator of this session, Mr. Yogesh Shivani. He is the Principal, Business Performance Improvement Consulting Group, NRI Consulting and Solutions. He is a mechanical engineer, and he's done a PGDM from IIM Kolkata. He has a career spanning over 12 years. He has worked with reputed organizations like Indian Oil, Engineers India, Tata Strategic Management Group, etc. He has spent more than a decade in management consulting. He has assisted numerous clients in the automotive, industries, and oil and gas sectors in navigating dynamic business environment. He's currently leading the Clean Energy Network at Nomura in India with a focus on green hydrogen. He has supported multiple clients in understanding the hydrogen ecosystem and creating tailored strategies for their businesses. So now the discussion is hydrogen as a new player in clean mobility fuels mix. I hand over the session to Mr. Yogesh Shivani for a 50-minute session. Thank you so much. And once again, requesting all of you to please ask your questions on Slido, and we will take the questions when 10 minutes are left for this panel discussion. Thank you so much.
Thank you, and am I audible? Yes. So firstly, thank you very much for everyone to join us in this post-lunch session. I know it's difficult, but really appreciate you all staying back and participating in this discussion with us. Now, hydrogen and natural gas are closely linked to each other. For the past 1.5 days, we have been talking about just one type of gas, which is practically methane. So let us shift the focus here and talk about another type of gas which is touted as the fuel of the future, and that gas is hydrogen. Both of them are interlinked to each other. Most of the hydrogen that we use today still comes from natural gas through a process called SMR, or steam methane reforming. But with the advent of green hydrogen and with the rapid evolution in the electrolyzer technology, the web of interaction between these two gases is becoming more complex day by day. Somewhere it is competing in the form of competing use cases such as refineries, petrochemicals, fertilizers, mobility. But some ways it is also complementing in the nature, in the form of co-firing in gas turbines, in the form of co-blending in the CNG and PNG networks, or also in the form of providing scale to manufacturers of cryogenic tanks and Type 4 tanks per se. So I would like to request my fellow panelists in helping us decode the mystery around this new fuel of the future, that what can we expect the future to be, how the future will treat hydrogen, and where all this interaction will help us in maintaining the goal of achieving 15% natural gas target by 2030 and even beyond. So in this regard, my first question is to Mr. Alok Sharma. So you have been working with the CHT, which is the apex body working in the technical domain for refineries, etc. Now, when it comes to natural gas, refineries are one of the most prominent consumers. And when it comes to hydrogen, they are the largest consumers of hydrogen in the country and also globally. And they are the ones which are expected to be the forebearers of green hydrogen adoption. So I would like to ask you that what tipping points do you see in the adoption of green hydrogen by the refinery sector, both commercially as well as technically?
Yeah, thank you, Mr. Yogesh. Well, see, as you indicated that, so refineries are the largest producers of hydrogen, and we use naphtha reforming as well as natural gas reforming to produce hydrogen. Actually, I will like to mention here that we started some hydrogen program when I was at Indian Oil in 2005, and a lot of apprehensions were there that why you are starting hydrogen and CNG. Basically, it was a hydrogen CNG mix work. So a lot of apprehensions were there, and even a lot of push was there that time in US also about hydrogen. But about, say, from 2009 to 2016-17, there was not much progress in the area of hydrogen. And it was basically dying down. So I can say that. But from 2017 onwards, again, there is a push in the hydrogen. But for our country, I think the major push has come towards green hydrogen rather than the blue hydrogen. In US, the push is towards both green as well as blue. Japan is also targeting blue and all green hydrogen. Europe is also going the same way. But our country has taken the lead in going directly to the green hydrogen. In this direction, I would like to mention that refineries have already taken action, and there is a lot of discussion which is going on in the ministry as well. And about 20% of the 5 million metric ton announced in the National Green Hydrogen Mission will be taken up by the refiners, and they have been given mandates sort of thing. Parallelly, Bureau of Energy Efficiency is also preparing the mandates to be given for the green hydrogen to various industries, in which refineries will be there, fertilizer will be there, then the steel sector and other sectors will also be there. But already Ministry of Petroleum has taken the lead, and about 20% of the 5 million metric ton of hydrogen will be, green hydrogen will be produced by 2030. Projects are being announced, and so already some of the projects, orders have been placed for some of the electrolyzer, the other things. But the only apprehension I see here that the issue which will come is that there are two issues, major issues in the production of hydrogen. One is the electrolyzer, because see, electrolyzers, though technology is well known, but the issue which is coming up is the supply of the electrolyzers. So all the electrolyzer suppliers are totally tied up, and the delivery times are more than 18 to 24 months. So this can be an issue. Then there will be, not at this stage, maybe at later stage, the water will become a big issue also for the electrolyzers. In this direction, National Hydrogen Mission has also given, like the incentive will be given for production of electrolyzers, as well as there will be some incentive for producing hydrogen. So $3 billion have been allocated, about 19,000 crores. So that allocation is already there, and MNRE is taking the lead in this direction, and there will be subsidy for the electrolyzer manufacturing, and there are incentives for producing hydrogen. So most likely the incentives which are likely to come are about 50 rupees per kg, which will stagger down to 30 rupees per kg in the next 5 years. So these are the incentives which will be given. But before that, only the Ministry of Petroleum has taken the lead, and we are going ahead with the program for green hydrogen.
Sure. Thank you, sir, for that response. I would like to extend this discussion to Mr. Hiren Mehta. You come from the renewable energy sector, and as we see, one of the largest contributor to green hydrogen cost is the cost of renewable power. Now, we have seen that the cost of solar, wind, etc. have gone down drastically when it comes to on-site production, but still a lot of use cases would be the on-site production model where the electrolyzer will be installed at the site of consumption itself. And since we don't have a 100% green grid, the only way that hydrogen could be green is through open access, which has its own challenges. So I would like to ask you that how will you ensure, or how the industry will ensure, that green power is provided to all the electrolyzers, irrespective of the location, whether it's on-site or off-site, throughout the future?
Thank you, Yogesh. Let me start with one thing, which is we all should take a proud about, that many countries has put up their policies for the green hydrogen, like India. But having said that, India is ahead of many countries in this race. Number one. Number two, what happens, in case of I'll just very briefly, I'll tell that how one can produce a green hydrogen, that we need a renewable power. And renewable power is then utilized in electrolyzer to split water to get a clean hydrogen. Now what happens that where the renewable power is available, hydrogen may not be required, as you said, right? Hydrogen is required where there is a consumption. As Mr. Sharma said, refinery is one of the key segment where hydrogen will be utilized. Now the refineries in the countries are located in the various places, and same place, we may not have. We don't have the renewable power production or generation plant available. Generation of the renewable power is generally done at the places where there are good higher CUF of the solar and very high intensity of wind, so that we can get a high generation of the power with the same amount of capacity invested. Like in our country, Rajasthan, Gujarat, Tamil Nadu are the states in Andhra Pradesh where such kind of high intensity of the wind and high CUF of the solar is available. Now, when you generate there, you need to bring that electricity to a consumption point, because still in the world there is no technology has been. There are technologies, but it's not yet developed to transport hydrogen from one place to another place in efficient ways. So what government in India has done, second thing is that they have utilized their grid. India has a large grid which is around more than 400 gigawatts. So government of India has taken a step that for 25 years, one can generate power any place in the country and can transmit to a place where hydrogen generation is required at free of cost for 25 years, which is a massive steps. That really gives edge to the India compared to many other countries who are also wanting to produce green hydrogen and therefore green ammonia as a derivative. So coming back to one more point that while we have this grid available, grid in our country is divided into we have a central grid, we have a state grid, we have a discoms. So government also has taken steps to integrate. Grid are already integrated, but state regulation is also now putting up the policy wherein this grid would be available to transmission of the power at free or maybe at very minimal cost. This makes India one of the cheapest hydrogen producer in the world. Now coming back to the point that what is required? What is required is all state governments needs to have a policy which the central government has it in the ISTS network to transmit power from generation to consumption. And second very important point is that this grid may be sufficient for transportation or transmission of the power for certain years, but going forward, we also need to expand this grid. So this way, India becomes one of the very attractive place for the generation and production of hydrogen in the world.
Thank you, Mr. Mehta. Now I would like to extend the discussion to Mr. A.P. Singh. Being a part of PESO, which is the apex body working on the safety of petroleum natural gas installations, now hydrogen is highly corrosive, it's highly explosive. And if the cost will allow, then we'll see mass deployment of hydrogen, most of which would also be in the mobility use cases. So what regulatory interventions do you foresee which are required to make sure that hydrogen across the value chain is handled safely?
Good afternoon to all of you present here, and thanks, Yogesh. Actually, any fuel, maybe petroleum oil, maybe gas fuel, these all are always highly flammable as well as explosives in nature. And for that only so many statutes, so many codes, so many rules and regulations are made. No doubt several, in all countries, they are having their own codes on the basis of which it's controlled. In India, as you may be aware, that Petroleum and Explosive Safety Organization is also one of the agency or one of the organization which controls the public safety whenever anyone is doing any petroleum, oil or gas related works, like its production, its possession, transportation, and its uses or handling. These all, since all are associated with a highly inflammable products, and hence danger is everywhere exists. So for these all, we have to take care, we have to follow the rules and regulation. Similarly, hydrogen is also one of them. As if we see in the history, when initially vehicles came, petroleum, oil were used, then several types of upgradation like ethanol addition, like other so many octane number increasing, cetane number increasing, for their quality products we are improving. And by that there are some additives are being used by which they may be slightly more highly explosives, or they may be more dangerous because they are having different type of properties. So everywhere we require that attention is required, or more and more stringent rules are to be added or amended for the safety, public safety, to ensure public safety. Similarly, when hydrogen is coming as a green energy, replacing these all, as we know that this reduces the maximum carbon emission, and almost at the 2070, we are planning that there it will be zero carbon emission. So in that line today, at least in India, we are only doing prototype, means fueling station where hydrogen is being used. Till now, in America, no doubt, USA and other countries, they are having the fueling stations. But in India, if some of you may be aware that only few companies or agencies are having taken approval till now, like one Indian Oil, well known, they were also working on HCNG. Later, probably that has not yet been much go ahead. It was at R&D level only. And after that, on hydrogen as a fuel, automotive fuel, they have again taken the R&D Faridabad. Similarly, IOC Baroda have also taken one, and probably they have started also to some extent. Now Reliance as well as NTPC at Leh, they all have taken the approval, but all are prototype and none of them are green hydrogen. Still, they are going to use the hydrogen not generated or produced by renewable energy. It is being, since only they are allowed to do this prototype who are already producing the hydrogen at their own. Maybe NTPC, maybe any refinery of Indian Oil or Reliance. Only they are now given who are having their own source of hydrogen, and they are doing. But when we are talking about the its commercialized or public, it's needed the proper code, proper amendment in the gas cylinder rules. Since these all are controlled by the either Explosives Act 1884 or Petroleum Act 1934. In the Petroleum Act 1884, in gas cylinder rules, there is no provision at present for the hydrogen fueling stations. It is, no doubt, it's already in process. BIS has also not any code for this till now. So they are also in process. Probably in the next 3-4 months, they will be able to give the code by which we can control it. But at present, it is only in the R&D stage, and you can say in trial and development going on. So that way it's running. Second part, what's coming, that is the, it's in the, means in the, when it's a large deployment, large scale deployment of hydrogen. Definitely, if you can see today only, we got news that in USA, one hydrogen bus, hydrogen fueled bus has met with accident. During the just fueling, it has blasted. It's today's news only. So everywhere, there is danger is everywhere, accidents may be anywhere. So no doubt we have also to take a lot of care in coding. We cannot say that this is like the CNG or LNG. CNG and LNG having different combustible nature. Hydrogen, you are very well aware that it is odorless, it is colorless, its flame is invisible. So whenever you are going to use it at the commercial level, it is very difficult. When it will, you will see its, feel that there is heat, then only you will be able to know. And like in LPG, like in CNG, this mercaptan sulfur compound is being used for the safety point of view or for the smell. But here what will be? Hydrogen is so light in nature that mercaptan will not be able to come out and flame will come out of the hydrogen. So definitely this sulfur present mercaptan system will never work in hydrogen when it is used as fueling. This is also a big problem, big challenge. So in this case, the we have to make very different codes, like CNG, and this is being given in the, as some may be known, that it is in the forms G ARP gas cylinder rules, but it cannot be given in that form because it is totally having the different characteristics. So it's compressors, it's dispenser, it's all the valves, everywhere. These all requiring a different type of, even the safety distance, these all will require a different code, different type of means credential, different type of its property. So accordingly, this code is to be firstly made, then only commercially it can be used. When we come towards its risk, definitely we should go towards the three things. First, its physical properties, what I have told you already, because it is highly flammable. Its flammability range is from 4% to 75%. Even in oxygen, it is up to 95%. And very ignite at a very low, this one. So it is very dangerous one, no doubt. So one part is this one. Second, this hydrogen gas is very, means it is, you can say, whenever it is filled in any cylinder, not all materials suit it. So sometimes it reacts with that, and after a few years, it may explode. So we have also to take care that what type of material is being used for the cylinder in which hydrogen is to be stored. And third, it's definitely, as Mr. Mehta was telling, it's what is the green hydrogen we are thinking. If we talk about the distributed hydrogen or hydrogen to be manufactured at every stations, fueling station, then there is need of its generation at that point. That may be only at present what we are thinking, that is electrolysis. So by electrolysis also, as renewable energy, if you will provide, then this will also require a lot. And that is quite expensive. Due to that, we are not able to decide till now how it can be used or how it can be proceeded. Next, one more very new emerging thing is coming, that is a turquoise hydrogen. This turquoise hydrogen is a new concept, and this is being produced by the methane pyrolysis in a different type of system, that is microwave hydrogen generation. Probably in some time it will also be used here in India, in NCR. In this carbon is generated in the form of solid, and it can be stored and it can be even sold. And the main thing is the electricity what is used, that is nearly 1/5 of the electricity what is required in this electrolyzer. So these all are we have to take care. So no doubt hydrogen will also be developed and it will be used as a fuel in due course of time, because we are having a lot of time at present. We are coming at present towards LNG. We are spreading the network of CNG all over India. It is also yet to come. So we are having the time, but definitely hydrogen is the only remedy which will definitely meet our zero carbon emission requirement of not only the nation, of the global also. Thank you.
Thank you, Dr. Singh, for the elaborate answer to that. Now, lastly, to close the loop, I would like to ask Mr. Rohit some questions about the carbon markets and how hydrogen is participating into that. So, one of the use cases of hydrogen which everybody is exploring to get a better ROI is the export of green hydrogen in whatever form. And we recently saw that the government of India is planning some bilateral ties with countries like Japan under the joint crediting mechanism, so that the hydrogen produced in India is also eligible for carbon credits. So this is a topic which is new to India. We don't have a carbon market as such. So you being from this industry, what is this JCM mechanism and how can it help in making attractive use cases for hydrogen export in India?
Thank you, Yogesh. Yeah, thank you, Yogesh. And first of all, I'd like to mention that green hydrogen is getting a lot of financial incentive from the government of India. And like the government of India has announced that 180 billion incentive in the coming years to green hydrogen. And to reduce the cost is one-fifth, like 150 to 200 rupees range, so that it can be actually fit to hard to abate sector like transportation, shipping and other sectors and reduce the emission. Second, there's a very important point I was going through today that by 2030, Government of India is also aiming to reduce import of fossil fuel of value 1 lakh crore rupees. So that is going to help us by reducing 50 million metric ton of GHG emission. And that will really help us to achieve net zero goal in the coming years as we have targeted. That 2070 is our net zero goal target as Government of India eyeing for that. At the same time, after government incentive, there are various other incentives are coming in the field of green hydrogen. That one of the best incentive is carbon credit incentive. And carbon credit incentive is coming, there's a multiple ways we can get the carbon credit incentive. And there's a multiple carbon market existing right now, even in India. Like one carbon market, we already have that Indian carbon market we have launched recently. And it is going to be functional very soon. But at the same time, there is no methodology approved in Indian carbon market because we largely have gray hydrogen right now, or hydrogen coming from source from natural gas or source from coal. But at the same time, if you are migrating from natural gas, coal to green hydrogen, renewable energy source, so there is no methodology available in Indian carbon market. It will take some time. I think the market is going to mature in 1 or 2 years' time, where Indian corporates or the project, the companies, the activities, which is coming under national determined contribution, which is going to meet their NDC requirement or net zero requirement or government compliance. So that can be benefited. The second market is CDM market, like Article 6.2 as per the Paris Agreement. That clean development mechanism is still there is no methodology available because India is a front runner and we are taking lead in the green hydrogen so far. But there's certain mechanism we are already developing with CDM mechanism. And one mechanism, I would like to mention the name, that this is in the pipeline and name is like NM0381. So that mechanism will help us to get good carbon credit revenue or carbon credit incentive in terms of emission reduction from hydrogen production from renewable energy as a source. This is the project which is going to approve in coming 2-3 months' time in CDM mechanism. And second methodology is coming, which is hydrogen production from methane extract or biogas. So there are two areas where India as a country can take the lead in terms of generating high carbon credit. And we have also calculated that how much carbon credit we can generate from the basic calculation. So we'd like to mention that we can easily generate, if you are going from natural gas to converting from natural gas to green hydrogen, we can generate around 15 carbon credit per kg. And if you migrate from coal hydrogen to green hydrogen, we can generate 25 credits per kg. And in that scenario, that every credit is going to give us around $80 to $100. So if you calculate that 1 kg from natural gas to green hydrogen, if you are converting, and we are getting 15 credits, 15 into 100, so $150 potential revenue we can generate from carbon credit. And that can be the huge money in terms of reducing the price of green hydrogen in this country and making us viable for all of us. And another market, what we have in the green hydrogen is Article 6.2, which you guys asked about JCM, Japan Carbon Market. So Government of India is in the process of doing collaboration with Japan. And there's a 13 technology sectors which government has approved that under 6.2, in these 13 technology sector, any bilateral and multilateral tie-ups can be done. And that respective countries can meet their NDC by doing investment in 13 technology sectors in India, where green hydrogen is one of the important area, and ammonia is also there. So green ammonia is also there, carbon capture technology is also there, offshore wind is also there. So these are 13 technology where government is also eyeing to collaborate, join hand, inviting technologies in this country. So that these respective companies or countries, by compliance, this is a compliance market actually. This can happen only from government to government collaboration as Article 6.2, where these companies can easily come and invest in this country and get benefited from the carbon credit and meet their NDC in their respective countries. So there's a third area where the lucrative opportunity in the carbon market. And the fourth carbon market, what we have, which is called International Voluntary Carbon Market. And International Voluntary Carbon Market, I'm happy to share that India is taking lead. So far, we have beaten China last year. And the entire world is eyeing for India as a destination to develop carbon credit and meeting their NDC and meet their carbon neutrality target. So India has 30% market share in this domain right now. And as per the latest McKinsey data, by 2030, we are expecting around $450 billion FDI in the country from the carbon credit revenue. And there's a tremendous scope, apart from green hydrogen. There are various other areas where the entire world is eyeing to invest in this country. First is mangroves, actually, it's a blue carbon. We have 70% coastal area. This is the advantage, natural advantage which you have as a country. And there are various projects which is going to implement it on the PPP model. So it's going to happen. And the government is recently launching MISTI scheme for that. Apart from that, we have various forests in the northeast area and other part of the states like South India and other part. So forest conservation is also there. So these are the areas where green hydrogen, nature-based solutions, and other areas. This is also going to give a large number of employment, as recently we have mentioned in the Hydrogen Summit, that green hydrogen is going to give us a 6 lakh job in this country. So green hydrogen is not coming with only energy resource as per se, but is going to develop complete economy and infrastructure of the country and helping us to achieve a net zero goal soon. So, yeah.
Thanks, Mr. Rohit. I think the revenue figures that you quoted are quite impressive and lucrative for anybody looking to invest in the green hydrogen ecosystem. Now, circling back to Mr. Alok Sharma, so we talked about the green hydrogen part in section 1, but there is this unsettled debate between blue hydrogen versus green hydrogen. Now, refineries particularly, but also the fertilizer plants, they all have big SMR assets in their facilities. So what, according to you, is the right path for them? Should they opt for green hydrogen directly, or does the path to green goes through blue?
See, blue hydrogen would have been the best choice for refineries. But the way the mandate is coming, it's we have to go for the green hydrogen. So the only answer is that we have to go for the green hydrogen only. Like I told you that in the other countries, they are going to consider like blue hydrogen. Like in US, there will be rebates with respect to the CO2 emissions. There will be some $3 rebate per kg based on the lowest emissions, and then it's staggered down to $0.6 per kg of hydrogen based on the CO2 emissions. So those sort of things are there in US, and other European Union is also considered the same way. But in India, I think the focus is only on the green hydrogen. So this is going to come as a mandate, as I told that B is already formulating these mandates, and I think we'll have to adhere with that only. So just want to add here that regarding the pathways for production, we are also eyeing to have like biomass gasification for distributed application. But the only thing is that the current mandates which are coming up, so we'll have to have like the captive use of hydrogen will be the first priority. Because once you transport hydrogen, so it involves a lot of cost. Because I can just mention here that still what we produce hydrogen at refineries at about $2. But if you go and buy hydrogen, that's about 1,000 rupees, even 700 rupees or 800 rupees a kg. And for high purity hydrogen, it is about 1,000 rupees a kg. So this is the margin which is there for the transport of hydrogen. So transport technology and storage technology for hydrogen has to be basically targeted before the hydrogen usage in the transportation comes live. Japan is going in a big way in transportation, but they are already having more than 200 stations now for hydrogen. They are importing, they are giving incentives for hydrogen. They are importing hydrogen from Australia. That is through coal gasification, because that is through coal gasification, and then that after that the Australians, they are doing some carbon sequestration also there. But ultimately Japan is getting green hydrogen, sort of green hydrogen. They are also getting hydrogen from Brunei, which is on the basis of liquid based hydrogen. So that is also going on. So those sort of things are also going across the world. Then ammonia is also one of the pathways for transporting hydrogen. Then methanol is also being considered. So various pathways are being considered for green, but ultimately for India, I think the focus is only towards green hydrogen right now.
Thank you, sir. You mentioned about transport being an important element in the hydrogen value chain. I would like to ask a related question to Mr. Mehta now, that your company ACE is also focusing on the other derivatives of hydrogen, most importantly, green ammonia. You have planned assets in India as well as in Oman. So how do you see the future? Do you see hydrogen dominating the use cases, or do you see derivatives such as green ammonia, etc., they will be dominating the use cases? What kind of matrix can we expect in the future?
Hello. Yeah. That's a very interesting question, you guys. As Mr. Sharma said, transportation of hydrogen is still under development, efficient way of transporting hydrogen. So green ammonia is as we all know, is a derivative of the green hydrogen. The countries who cannot generate hydrogen themselves have, this point in time, no option but to import green ammonia. As an example, countries like Japan and Korea. So green ammonia production technology is probably 140 years old. Haber-Bosch process, is being used in all countries for many years. Like in India, almost 97% of ammonia is being used in the fertilizer sector. They use gas to produce ammonia. So that's a very old and known technology to make the ammonia from hydrogen. Now, ammonia versus hydrogen. As those countries who cannot produce hydrogen themselves are required to import ammonia. Simple reason is ammonia can be transported and converted in liquid at minus 33 degrees, whereas hydrogen is required to reduce its temperature minus 250 to 59 degrees centigrade. Requires very high energy. At the same time, its molecular weight is very, very less, so it has a very high BOG while transportation. BOG is nothing but the loss of the gas while transporting from one place to another place, boil of gas. So, because those countries are going to import ammonia, they have also started development to utilize ammonia directly. As an example, in Japan, many coal-fired turbines, now the company like JERA is targeting to co-fire ammonia with the coal-fired steam turbine around 20%. That's one. Number two, GE and IHI is also developing turbines which can be directly run on the green ammonia. And in case of shipping industry, as far as to match the IMO 2050 goals, ammonia has been viewed as one of the emerging fuel to use in the shipping industry. So hydrogen will be used in those countries directly, as an example like India, where it can be generated and also utilized. And those countries who cannot generate hydrogen will import ammonia and you will use ammonia. As an example, US like India would also directly use the hydrogen. Other than this, there are technology also people are developing which will crack ammonia efficiently and convert into hydrogen. Then hydrogen can be directly used in the turbines and many other ways in refineries as well. So ammonia and hydrogen both will coexist. Some countries will target to use hydrogen directly, who can generate. Some countries where cannot be generated, they will use ammonia. But at the same time, the technology development is also happening wherein ammonia can be used directly. Thank you. And just to tell you one more thing, like our country, government of India is focusing to become a net exporter of the hydrogen. The way to do it, to convert hydrogen into ammonia, and the large size project is being planned in our country to produce ammonia, mostly in the coastal areas, and to export from India to those countries who is required to import those ammonia. So do a little bit of marketing of my company as well. So ECME Group is also setting up such a project in the country to produce green ammonia, and such projects are actually highly capital intensive, required almost $6 billion of investment to generate 1 million ton of the ammonia. Thank you.
Thank you, Mr. Mehta. Now again, moving on to Dr. Singh. So we spoke about general regulations in the hydrogen handling in the first question. While the government of India is planning a lot to localize hydrogen manufacturing equipment in India, but nevertheless, there's going to be a substantial section of society which will lean towards imports. And since China is having a head start in electrolyzer and other component manufacturing, most of these invariably will be landing to India from China. Now, we have all had good and bad experiences with China-made components in factories and all. So how do we make sure, or what regulatory interventions are required to make sure that whether it is import or domestic, it is safe for the country?
You may be aware, in one webinar, our Prime Minister Modi had told that first thing, that topic was probably green growth. So in that he told that first thing, we have to increase our production of renewable energy. Second, to reduce fossil fuel dependence. Third, our economy should be now gas-based. So in that next step, one national green hydrogen mission was organized, was made. And nearly 19,744 crore rupees already allotted for green hydrogen manufacturing or production in India, so that India can be a global hub for the manufacturing of this green hydrogen. So in that we have to take all those precautions, and like where the case of China's import from China is coming, our all even today CNG compressors and all other equipments what we are making, maximum fine or small parts of that is coming from there. Even CNG cascade, in CNG cascade, several cylinders are coming from there. When this COVID-19 was going on, I was also in the committee, so I'm remembering that a huge number of cylinders were imported, not imported, they have given to India. So from all countries it was coming. But everywhere there are so many agencies in our country, including PESO, DPIIT, Ministry of this Petroleum and Natural Gas. We have the stringent norms. No doubt, as I have told, that this hydrogen is an embrittlement gas, so it has a nature to react with the material of the cylinder in some cases. So definitely there is a chance, immediately we are taking, purchasing, or someone is importing, and that time its behavior was normal, but after some time it may explode. So definitely we have to make the stringent norms for import of cylinders from China or elsewhere. And simultaneously, we should have like earlier we were allowing the third party testing. If anyone is doing in China, we were accepting that. But now in the case of hydrogen, definitely we have to take care that all the batch tests or the testing should be only in India, and it should be taken all the approval from PESO as well as from other authority for the import license. These all should be taken, it should be cleared, then only it should be allowed to come in India. So that way we can definitely prevent such spurious cylinder or which cylinders which are not quite safe. So we have to take care on those things. So I think that will be resolved. It is not a problem because for a long time it is the means in several cases, maybe oxygen plants, bigger plants, cylinders, smaller things. Everywhere we are getting sometimes very low quality products from China. So we have to take care our own. Our norms should be stringent. We should have proper testing, and then only, and it should be tested by accredited laboratories in India only. Then only we should allow for the import of such things. Thank you.
Thank you, Dr. Singh. Hopefully, the industry will come forward and localize these components so that we don't have to depend on imports at all. Yes. So, lastly, because time is limited, I would like to ask another question to Mr. Rohit. You talked about the voluntary carbon markets in the previous round, and India being one of the significant contributors to it. Now, on 30th June of last month, I mean, just few weeks back, the government of India also notified the CCTS system, the carbon credit trading system. Now, how linked is this system with the global markets, and will we see a competition between generators of credits in CCTS versus the global VCS registries? How linked are they, and if not, what needs to be done?
Thank you. So, in the last time we were discussing about the carbon market, so we discussed about there are only 4 kinds of carbon market existing in India right now. One is Indian carbon market, which is launched recently in the month of mid-June. But Indian carbon market right now is completely focusing on NDC requirement, National Determined Contribution requirement, which India has pledged that by 2030, how much emission India has to reduce. So government is coming with a lot of rules and policy, which is cap and trade mechanism, which we used to have earlier as ECERT and PAT. So similar mechanism has been developed where government is going to fix emission reduction target for a specific sector. And that emission reduction target in India, we can do it by Indian carbon market as an option. So Indian carbon market will be completely based on compliance market. So another carbon market comes, which is voluntary carbon market, like you guys is saying. So voluntary carbon market is, there's no link between compliance and voluntary carbon market, because voluntary carbon market motivate and promote to be carbon neutral or net zero by themselves. Suppose I'm a company, I'd like to be net zero, even if I'm not coming under NDC requirement or any government compliance. And since my large number of businesses in the European nations and other part of the world, so I would like to voluntarily be net zero or voluntarily be carbon neutral as a product and service. So voluntary carbon market has played a very important role in that area. That really give you the boost up to your export and build your brand and build your imagery of the company to get more and more business around the world. And in the voluntary carbon market, there's various options like VCM mechanism, which is US-based mechanism. Then GS is a gold standard mechanism. GCC is the Global Carbon Council. So all this mechanism is already existing right now. But the major challenge is that there's no methodology of green hydrogen is yet approved around the world. So a lot of development is happening, and as a Carbon Market Association of India, with our members, we are also working closely with developing methodology in CDM and other part of mechanism, so that India as a country can get high incentive in terms of carbon credit incentive when we produce green hydrogen and we migrate from coal and natural gas as a source of baseline to the green hydrogen. At the same time, there is a certain challenge which I would like to mention in this forum. That first is that every project, when we apply for carbon credit, to generation of carbon credit, they really focus on 2 areas. One is baseline. So we'd like to know that where we stand today, how much emission we are doing today. So data management is really important when we are migrating from coal or fossil fuel to green fuel. So data management is really going to help us to create a baseline and help us, our project, to register in this respective mechanism. Second is that additionality is area, where we'd like to prove that why you need additional fund for being carbon neutral or being sustainable. So that question, that area we need to prove. So 100% funded project from the government is not able to get the carbon credit because there is no additionality question is yet to be proved. So there is a tremendous scope when we plan business, when we plan any business opportunity or migrating to the green hydrogen. We should really focus about how PPP model can work better, how community involvement can work better, how industry participation can work better, so how MSME participation can work better. So that collaborative approach, cohesive approach, can really help us to get a large carbon credit revenue. And recently I was in Nepal last year, and I realized that in the small nation, but they're really focusing about the cohesive approach, and they're getting $45 million from the World Bank because what they have done, all the forest they have given to community, and that really helped them to qualify their project for carbon credit. So this is another area. And third important area is that digitization of carbon market is going to help. So that is really important because a lot of data and a lot of methodology, and it is really complex. So we had to simplify this process. And the most important challenge as a country we are going to face where green hydrogen can help us, which is called cross-border adjustment mechanism, which is going to be applied in 2026 January, where 5 sectors like steel, cement, aluminum, and fertilizer. So they have to give carbon tax if you're exporting this project to Europe. And the carbon tax in the price of EUTS, which is around $100. So green hydrogen has to play a very important role to reduce these kind of taxations and help us to be a carbon neutral product and service. Yeah, thank you.
Thank you, Mr. Rohit. I can see a big time's up there. So do we have time for any questions? Yeah. Sure. So I think most of these questions are repeating from the previous sessions about percentage H2 blend, which were answered previously by different participants. But I saw one question which is not here now, which was about the direct use of green ammonia into vehicles. So Mr. Mehta, if in case you are aware of that, is that one of the applications of ammonia?
Yeah, that is possible to use the ammonia directly into vehicles. There's a company in the US which is developing this technology. Ammonia is nothing but the source of energy, and it has a very high density of having very high density can have a good source of the energy. And there's a technology wherein it's simplified, wherein ammonia is getting converted into hydrogen, and with the use of fuel cell, it's directly getting consumed and can work in the automotive sector. This one, and other thing is in the shipping industry, anyways, in the engine also ammonia would be directly fired. And that technology also, like that, there is a MAN Engineering and the Wärtsilä are the one who are developing this technology as well.
Yes, please.
So this at CNG, regarding blending of hydrogen in natural gas. So Indian Oil has done a lot of studies regarding this, and blends of about maybe 1% to 30% were used in CNG, hydrogen blends, and 18% of hydrogen by volume was optimized to be used in the current CNG engines. And a trial run of 50 buses was done at Rajghat Bus Depot also, about in 2021. And what it resulted in, a lot of reduction in the CO and hydrocarbon emissions and about 5% increase in the mileage. So that has been done. And as far as pipelines are concerned, there is no guideline as such. It's as per the standard, only 0.2% by volume can only be blended in. It's allowed in hydrogen is allowed. However, GAIL has done 2 pilot studies. They have done one with 2% by volume in Indore, and they are going ahead with 5% by volume. However, I can just mention here that there is a standard 193 for CNG, and there is a standard 197 for ISO 197 for hydrogen. I convened one of the one of the working groups for ISO 193. Only we have finished last week. Only we have finished the activities, and so this was basically how much hydrogen can be blended in natural gas and how this will affect the other ISO standards. So it has been finalized that 20% will be allowed. However, this has to come formally in India also. So 20% of by volume will be allowed for CNG blending. So this has been a recent development which is happening.
Sure. Thank you, Mr. Sharma. I think, and just the last question in case we want to touch upon that, that while mandates are coming and everybody has to adopt that, but what could be the business model which will make a hydrogen plant profitable without any mandates?
Yeah, at this point in time, certainly, the green hydrogen is the expensive than a gray hydrogen. So if approximately cost of the gray hydrogen is $2, then green hydrogen is around $4. One area which will make without mandate is, sir has just now said that, can be the carbon market. The carbon market itself will reduce the gap between gray hydrogen and green hydrogen by taking benefit of the carbon market. So by reducing the carbon emission, that can be traded in the carbon market, and India is actually very actively working on developing this carbon market. Number one. Number two, technology development, which is also going up very, very well. As an example, currently the any electrolyzer efficiency is around 65% or 70%, which is expected to go to 90%. When it will go to 90%, the requirement of power for generation of the same amount of hydrogen will reduce, and therefore it will directly impact the cost of the hydrogen. Because currently almost 60 to 65% cost in the green hydrogen is the power. So technology development and development of the carbon market will make it possible to have the green hydrogen competitive with the gray hydrogen over a period of time. It's difficult to tell how much time it will take, but it would not take more time. It's expected that by 2030, it will be having the same price of the gray hydrogen and green hydrogen.
Just one point to be added here, that the major cost for a electrolysis process is the power, because we use 55 units per kg of hydrogen. So power cost also has to come down. So that is one of the main things, because though we say that we are producing solar, hydrogen, other things, but the actual price what people are getting is not less than 5 or 6 rupees. I think you can add on that.
Yes, the 55 units that sir said is required to generate 1 kilo of hydrogen, and India has actually reduced the cost of power like anything, and at this point in time we're probably having only 3 cents per unit of the cost of the power, and which is also expected to go down. The one point which I would like to add on the mandates. See, mandates is only required to have a start of utilization of the green hydrogen. Once it will be utilized with the economy of scale, with the more number of electrolyzers would be required, more technology development would happen, and that's why it will bring the cost of green hydrogen down. So it's not that mandate is going to stay long, and mandate, even if the mandate is going to come, it is going to come for the very small percentage of the hydrogen will be to be used as a green hydrogen. Thank you.
Thanks. So I think I'll just take one last question which was flashing there, which is the difference between an HCNG and a CNG filling station.
Yeah, that is, hello. Actually, definitely HCNG stations can't be same to CNG. Due to that, it's as Alok ji was telling, that they have trial in R&D center Faridabad, and by that buses, 50 buses I think, were trial in that. So this is still, there is no any code or any amendment in the gas cylinder rules made. So HCNG is totally different from CNG facilities. You can add more.
Yeah, actually, this hydrogen station, what Dr. Singh was saying, so Indian Oil has set up one hydrogen station at Gujarat refinery. So this is at 350 bar pressure. So there will be a difference of pressure, there will be a difference of storage. So it will be a totally different station. So those things will be there, and it will be a costly station, because I think CNG station is about I don't know the exact price, but at least hydrogen station will be about twice the price of CNG station, at least.
Thank you. I think we have ran out of time. So I would like to thank all of you for taking out time and participating in this very good discussion. And I think the public was also quite interested, given the number of questions that we received.
Yes.
So thank you very much, everyone. I'd like to close this panel.
Thank you so much. Can I have a round of applause, please, for this panel? I would request the moderator, Mr. Yogesh Shivani, to please present mementos to our panelists. A memento to Mr. Alok Sharma, Executive Director, Center for High Technology, Ministry of Petroleum and Natural Gas. A memento to Dr. A.P. Singh, former Joint Chief Controller of Explosives, Petroleum and Explosive Safety Organization, DPIIT, Ministry of Commerce and Industry. To Mr. Hiren Mehta, Chief Commercial Officer, Acme Group. To Mr. Rohit Kumar, Secretary General, Carbon Markets Association of India. May I request Mr. Kulbir Singh, Advisor of Messi Frankfurt India, to please come up and present a memento to the moderator, Mr. Yogesh Shivani. Principal, Business Performance Improvement Consulting Group, Nomura Consulting and Solutions. Thank you so much. Can we huddle for a group photograph quickly?